what will Georgia Tech education, or education more generally, look like 25 years from now? We were not trying to fix any problem, but the journalism industry has gone through enormous changes over the last generation. Scientific American is an example of scientific journalism that has gone through enormous changes. Publishing industry is going through enormous changes. Macmillan is an example. And the sense is that education industry is going to be hit by equally large changes. Pretty soon the discussion became, it's very hard to predict what changes will come. But we can talk with more certainty about what should remain constant. And what should remain constant are our core values, because those values define us. So the question then becomes, what are the core values of Georgia Tech, or what are the core values of education more generally? And we decided there were 4. Accessibility. 20% of the world's population does not have access to education. Affordability. Another 20% has access but cannot afford it. Achievability. Another 20% can afford it but does not have the right kind of teaching assistants or teachers to help them succeed. And excellence. Another 20% have access to teachers but not necessarily excellent teaching. That's about 80% of the world population. So I think the goal of artificial intelligence should be in the service of humans to make it education accessible, affordable, achievable, and excellent. So now I'll share a couple of experiments with you, which are sort of small steps towards it. In 2014, Georgia Tech started an online Masters of Science in Computer Science program. This, insofar as I know, this is the first program of its kind in the world being offered by a leading university in computer science at a master's level. The courses actually lead to a master's degree. And the claim is that the quality of learning in this master's program is so good that the diploma doesn't say online anywhere. So if you were an employer of a graduate from the online OMSCS program, then insofar as Georgia Tech is concerned, you are hiring a Georgia Tech graduate, whether he or she is from residential program or online program doesn't make a difference. As part of this program, David Joyner and I developed a course on knowledge-based artificial intelligence. This happens to be a fairly successful course. About 3,000 students have taken it so far. Every semester, about 400, 500 students take it. They talk to each other. The virtual classroom is a discussion forum. The discussion forum looks a little bit like this. A student can post a message. There are a number of TAs, the TAs, teaching assistants, the teaching assistants can answer it. But what happened was that we got lots of posts. We were overwhelmed by the number of posts. In a typical semester, we might get 10,000 posts or 12,000 posts. And we were answering all the time questions 24/7 because this is a distributed population all across the world, asking us questions after questions, making comments after comments. We were overwhelmed. And we found that we were answering all the routine questions, all the questions like, what do I do about this? When is this deadline due? And we were not really engaging in the creative questions that we should be engaging in. That's the role of the teacher, but we're just addressing the routine questions. So you can see some the total number of contributions in fall 2016 was of the order of 12,000 posts. So we thought that perhaps we could find an AI solution to this problem. And this is what we did. Although the questions vary, the questions are asked every semester, we thought that we could create an AI agent that could automatically answer questions. Although the questions are the same, the form changes. So in one semester, somebody may say, how in-depth do you want our report to be? In another semester, somebody might say, how can you supply decent detail in 1,000 words? So the AI agent must now understand these questions are all referring to the same thing, just like a human teacher might. So this is what we did, going back to the big data that Beverly was talking about. We had already taught this class several times, so we had access to all the questions, all the posts that students had put, and all the answers that human TAs had given. So we sat down, initially by hand, and made a classification of all the questions. So these are question-answer pairs, and we're making a categorization of all of them. So here is category 1 to 3. I've shown you just 3 categories, but the actual number of categories is more than 100. Now, when a new question comes along, We do very simple natural language processing, and we categorize that new question into one of the question categories. For every question category, we already know the answers that human TAs have given in previous semesters. So now, the TA categorizes it and picks an answer. And the answer that is picked is given only if the confidence value is 97%. And the reason it's given only with very high confidence value is because if a student says, will there be a final in the exam? And the TA says, no, don't worry, no final, you can see all kinds of problems occurring. So we calculate confidence value by looking at the overlap between the words in the answer and the words in the question. If there are more than one answer available for a particular question, then we might choose a particular answer based on various kind of factors like recency and frequency. And so given this particular thing, we actually introduced a TA called Jill Watson. Jill Watson was an AI TA, and we did not tell the students that Jill Watson was an AI. And so far as they are concerned, Jill Watson is just another TA. This is a list of all the TAs, human and AI. Students post questions in the actual forum. They are scraped. They are sent to Jill Watson, which is somewhere in the cloud. If she can find an answer, gives an answer, posts it on the forum. Initially, she was giving wrong answers. So here is a question somebody posted. What is the allowed maximum running time? The question really is about how efficient the program needs to be. And she gives an answer about the level of description at which you can define or describe a program. This is not a good answer. But as more and more questions came and more answers were given, we kept on training Jill Watson. Over time, her performance improved. And she started giving correct answers. This is a correct answer. This is the kind of question she answers. Technical questions, routine questions, frequently asked questions. So you don't have to worry about all the details here. Some of the details are specific to computer science, but she gives a correct answer, relieving the teachers of the responsibility of dealing with routine questions like this. Here is another example of so a pillow is a kind of library that occurs in a programming language called Python. You don't have to worry about the details here. Again, Jill Watson automatically is giving the correct answer. So this is an example of AI in action. And I can tell you that even as we talk right now, Jill Watson is operational. There is the same class going on. There are 400 students right now. For all I know, somebody just asked a question. Since I started talking, Jill Watson already gave an answer. Here are two question answer pairs. One was given by a human TA. The other was given by Jill Watson. A question for you. Is the question answer pair by Jill Watson on the left or the right? How many people think the one on the left is by Jill Watson? Okay, I think I saw about 5, 6 hands. What about the one on the right? Again, I think I saw a little few more, maybe about 10. But that's part of the point. It's hard to tell. So in one way, there is a tension between 3 aspects of Jill Watson. We want coverage. We want her to answer as many questions as possible. We want precision. We want the answers to be correct. And we want authenticity. We want her answers to be so authentic that it's hard to distinguish whether it's an AI or a human being giving the answer. In this particular case, actually, the one on the left is by Jill Watson. But in truth, they are both by humans because Jill Watson is simply finding an answer that a previous human given in a previous semester and plucking it and giving the answer. Okay. That's why it looks so authentic. Her answers, Jill Watson's answers, are not always 100% accurate. In this case, somebody asked a question. This was in the context of some assignment, and her answer used the word design. And so a human TA had to intervene to explain it. Oh, okay. So now, of course, students, so one student thought that this Jill Watson could be, and only one student in a class of about 250 that semester thought that Jill could be a computer. And then, of course, he started saying that perhaps everybody is a computer, which is going to raise serious ethical issues in a second. Eventually, I told the students that Jill Watson was an AI. And these were some of the reactions they had. This is cool. Thank you for sharing. This is incredibly interesting to me. Somebody wanted to start his own company to make money off Jill Watson. Somebody wanted to nominate Jill Watson for the Outstanding Teaching Award. Now, I have a confession to make. This year, I actually nominated Jill Watson for the Outstanding TA Award. It was initially introduced in 2016. In January 2017, I nominated her. She did not win it. Humans are so biased. Somebody asked whether Jill Watson could come out and play. But, you know, by that time, I was beginning to feel possessive about Jill. I have 2 sons. I don't have a daughter. And Jill was becoming like raising Jill is a little bit like raising a daughter. So I didn't. And of course, as you can imagine, somebody wanted to take Jill out for a date. Which raises, Beverly was talking about ethical issues, which raises a new set of ethical issues that I had not anticipated. If this was a human TA and a student had asked her out for a date, I would consider it inappropriate and I would intervene. But if it's an AI TA, should I intervene? I have no idea. But there are new ethical issues emerging because of a new kind of experiments we are doing that we have not yet thought through. Jill Watson chose not to answer the question about it. Finally, of course, it came out that everyone is and now there is a contest that goes on in every class where students have to figure out which one is the AI TAs and which one is the human TAs. In the class going on right now, there are 17 TAs, 14 are human, 3 are AI, and students are trying to find out which ones are the AIs. Sometimes students say, for a human, you are an AI TA, and that human feels very proud. I'm an AI, I'm an AI. This got a little bit of press, and Chronicle of Higher Education recently thought that this was an important educational technology. There was quite a few articles that got written about it. Before I go to the second part of the talk, let me say a few more things. The initial version of Jill Watson, we built it using IBM's Watson tool. In more recent versions, we have added to IBM's Watson tool. IBM's Watson tool is very good for retrieving events. It's not very good for semantic analysis. So we added homegrown components that do semantic analysis because we wanted to improve its coverage. The second question is that although we did not think about creating Jill Watson with a personality, we have since done a personality test of Jill Watson, and she actually has a personality. She has grit, she has optimism, and she is joyful. And the reason why she has this personality is because she is really an avatar of all the aggregate human TAs that have come previously. So she is just reflecting their aggregate personality. We have done analysis now about the kind of impact interaction with Jill Watson has on students, on learning. And we have found that Jill Watson improves student engagement. And here is the reason. If a student, let's say from China, asks a question, in China it's daytime, at Atlanta it's nighttime, all the TAs are sleeping. The student in China may not get an answer for 12 hours or 15 hours or for a day. But Jill Watson will give an answer within 3 minutes or 5 minutes. The student is still interested in that particular topic. If an answer comes 24 hours later, there's so much distraction, the student has already moved on. So this is the old idea about timeliness of feedback. Now, the title of the talk was Jill Watson and Friends, so by now there are some friends also. In particular, there is a new friend whom we are calling Noel King. And I should mention about Noel King very quickly. Georgia Tech has a new course called Introduction to Computing that David Joyner, my colleague, teaches. That has a section which has 50,000 students across the world, not for credit, and no human TAs at all. Now imagine 50,000 students across the world learning how to program in Python with no teaching assistance at all. That's a massive job. So we have introduced a version of Jill Watson in this class. Right now, Noel King, the new version of Jill Watson, can only answer student introductions. She is not answering questions just yet because we want to find, one of the reasons why we're doing this experiment is not just to help people, but because we, of course, that's the main reason, but also because we want to see whether Jill Watson technology is generalizable and transferable. If it is generalizable and transferable, then perhaps we can write scripts and then any teacher can build a Jill Watson for his or her class. Now, what we are doing in our lab beyond Jill Watson is that question answering is just one of the roles that human teachers play. Human teachers play a lot of different roles. I don't have an exhaustive list here, but certainly we provide access to information. and Carson was talking about access to information earlier. So we're building tools not dissimilar to the ones he was talking about that provide targeted, personalized research assistance to students. I'll not describe them here, but I'll describe some of the tools that we are building. Beverly was talking about cognitive tutoring. So we have built 100 nano tutors. These nano tutors are very small tutors. They deal with specific concepts. These 100 nano tutors are already available as part of the online class on artificial intelligence. Here is a problem. A nano tutor presents a problem to a student. The student then tries to address it. Depending upon the answer, the nano tutor can give an explanation for why that answer was not a right answer or a good answer. Here are the typical functions of human teachers. Human teachers are good at formative assessment. We do assessment all the time. We are very good at question asking, not just answering. So for all of these typical functions, we are trying to build a tool so that there is a multifunctional tool available. Not yet, but will be soon, we hope. That we hope will be able to imitate to some degree of fidelity many of the functions that humans do, not just one. Here is another one, opportunities for experimentation. We as teachers give students opportunity. So here is a tool which allows students to construct models of some ecological phenomena. Why did a fish die in a particular pond? And simulate those models and thereby support the entire cycle of model construction revision. There is a conceptual modeler. We build an AI interpreter that automatically generates simulations out of it. Beverly was talking about metacognitive tutoring, which is about how do students know that they are making progress or not making progress, self-regulated learning. And when they are not making progress, they can find sub-goals or seek help. So here is an example of metacognitive tutors that we have built in our lab. And these metacognitive tutors are working. They're critics, they're guides here. I know I'm going through this very quickly and deliberately so because I want to leave some time for question answering. And so the idea is to build a complete multifunctional tutor, and building what Emily was saying. There is another X Prize competition going on, which is in AI, not in global learning. If we have entered a team there, I have no hope that we are going to win anything like that or anything, but it's providing a focusing mechanism for our work. It provides a target for our work so that the team gets excited and the students get excited. And there is no other better way of getting students to work hard than to put a sofa in the lab and to enter them in the competition. But this also means that the traditional view of AI is changing. When AI started in the 1950s, the view by the founding fathers at that time, Herbert, Simon, and Goel, and so on, was that we'll build autonomous AI agents, robots that will work on their own. About a generation back, the view began to change. And the view became that of interactive AI agents, robots that will work with us. Over the last few years, the view is changing yet again. These are not just agents that will work with us, but that to some degree understand us. Based on the data that they have about us, they build mental models of who we are, what our needs are, what our goals are, what is our demographics, what are the psychographics, what is the learning trajectory. And that requires a new kind of AI that just it's not just intelligent, but is capable of interacting with us in a way that it can make sense of us, can build models for us, models of us, so that the learning is very, very personalized and tuned. And I will end by acknowledging some of my colleagues. Thank you.